All right, so binary covalent nomenclature. So binary means a pair of things. Our nearest star system, Alpha Centauri, or Proxima Centauri, excuse me, is, I believe, a binary star system, two stars closely orbiting one another. So we're talking about binary compounds, is composed of just two elements. So covalent, we're talking about covalent compounds. Nomenclature means a system of naming. Nomen for name, clatura for system. So that means that this set of slides, we are talking about how to name binary covalent compounds. Now, covalent compounds are paradoxically more complicated and simpler than ionic compounds. They're more complicated because with an ionic compound, once you know the charges on your ions, you know how many there are of each. Sodium chloride, 1 plus, 1 minus, it's always a 1-to-1 ratio. Calcium chloride, 2 plus, 1 minus, it's always going to be a 1-to-2 ratio. You can't do that with covalent compounds because they can combine in any number. Nitrogen and oxygen are a really good example of this. NO, nitric oxide. NO2, nitrogen dioxide. N2O, dinitrogen monoxide. And on and on and on. So just knowing the elements isn't enough. You need to know how many there are. Okay? So that's what makes them more complicated. What makes them simpler is that all the information will always be in the name, and it will be directly related to the formula. Okay? So the way we name covalent compounds is we use a prefix to indicate how many there are of each element. If there's only one atom, we use mono. If there are two, we use di. 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, d is deca. You're adorable, but you're getting kind of annoying, Wesley. Don't worry, I'll take you for a walk soon. Get you out of that stupid cone. So you use a prefix to say how many there are of each element. And then you just drop the ending of the element and add IDE for the second guy. Sort of like with ionic compounds. So we have... Oops. Calm down, pup. So it's just the same sort of thing. Now, there are two exceptions. First up, we don't use mono in front of the first of the elements. So coming back here, it's nitrogen dioxide, not mononitrogen dioxide, just nitrogen dioxide. Second, if any of the prefixes ends in O or A, we drop the O and A in front of oxygen. Dinitrogen monoxide, not dinitrogen monooxide, just dinitrogen monoxide. Similarly, nitrogen tetroxide, not mononitrogen tetroxide, just nitrogen tetroxide. Oh boy, you are... what are you doing, dog? God damn it. You need to scram, pup. Go. All right. And second, nitrogen tetroxide, not nitrogen tetraoxide, just nitrogen tetroxide. All right, so beyond that, you're just going to need to memorize these. Again, they won't give you this chart on a test. You can go beyond 10, like if you want 11, it would be undeca, 12 would be dodeca, going up to 20, it's icosa. For 30, I believe it's tricosa. They've gotten really clever with the prefixes, but we're only going to need to go up to 10 for this class because we're just dealing with the binary covalent, and there's only so many things you can cram around a single atom. So here's just a few examples. As with everything else, there is a ton of practice out there. Easy enough to get practice. So in 2O5, 2 nitrogens means di. It's the first one, so we just named the element, so dinitrogen. Then there are 5 oxygens, so pent. It's not penta because it's oxygen, so just pentoxide. Okay. Remember, drop the ending, replace it with IDE. SO3. Okay. Be careful. There's no charge on this, so it is not the polyatomic ion sulfite. SO3 by itself is sulfur trioxide. Let's go a little bit different. BF3. First element is boron, and then there are 3 fluorines, so it is boron trifluoride. Okay. They'll also expect you to be able to go in the other direction. So if they give you, say, sulfur hexafluoride, that would just be S, and then fluoride means F, hexa means 6. So be able to go back and forth, memorize those 10 prefixes, and get a little bit of practice in. One last note. Hydrogen-containing compounds often have their own special name. So, for example, H2O, that's just water. NH3 is ammonia. It's very closely related to the polyatomic ion ammonium, which is NH4+. Then we have, say, BH3, which is borane. SiH4 is silane. PH3 is phosphane. You may be noticing a trend. So I kind of doubt they'll throw many of these at you on the test. They could, especially water and ammonia, but these others probably not. Just be aware that they tend to have their own kind of thing. All right, and with that, we are done with binary covalent compounds. I'm going to go ahead, take Wesley for a walk, get him out of the cone of shame. I'll be back and call it 15 minutes to do bond theory. We'll be starting Chapter 5. I will see you around.